d by dx or d by dt of t to the power n will be nothing but n t to the power n minus 1. And on the other hand, if I've got integral t power n dt, then this can be written as t to the power n plus 1 by n plus 1. So these are the only two formulas that we will be using for the calculus that is there. And as and when needed, we will look at other formulas that are there. Now, we know that there are three equations of motion. The first one being v is equal to u plus at. The second one, s is equal to ut plus half at square. And the third one, v square is equal to u square plus 2as. Now, all of these three we have derived graphically. So now let us go ahead and derive all these equations using integration and differentiation. That is the method of calculus that is there. The second equation of motion that we have to arrive at is s is equal to ut plus half a t square. Now for this, what are we going to do? We have displacement and velocity as well as acceleration. So we can go ahead and take the expression v is equal to ds by dt, because this is the only way we will end up getting displacement. So on rearranging, I will get this as ds is equal to v dt, or ds is equal to u plus at times dt. Since we already derived the first equation, v is equal to u plus at. Now we can go ahead and put the integral sign. Integral ds is equal to integral u plus at dt, or we can write it in this particular way. Integral ds is equal to integral u dt plus integral at dt, or integral ds is equal to u times integral dt plus a times integral t dt. Now we have to look at the limits. So when time is equal to 0, initial displacement is 0. When time is equal to t, the displacement is written as s. So let us apply the limits. On application of limit, my expression will become s is equal to 0 to s is equal to s is equal to u times integral t is equal to 0 to t is equal to t dt plus a times integral t dt. T is equal to 0 to t equals t. Now since we have done the integration in the previous step, we can go ahead, or for the previous formula, we can go ahead and directly do it. So the LHS becomes s times, or we'll do it once more, s power 0 ds integral s is equal to 0 to s is equal to s. And now we'll go ahead and do this simultaneously so that we don't have to come back to this particular part again. So what I will do is I will just go ahead and write whatever new formula or new values that I'm going to put it in red. So s power 0 is not going to affect, you're going to get the same expression. This is t power 0 and this is t power 1. So our expression now, since we have written this, we can go ahead and integrate it. So this becomes integral s is equal to 0 to s is equal to s power 0 when we do. So without the integral, let's go ahead and solve it. We will get s power 0 plus 1 by 1, which I'm just writing it as s, varying from 0 to s, is equal to u times t, which is varying from 0 to t, Now here we have t power 1. So that we will get it as t to the power 1 plus 1 divided by 1 plus 1, varying from 0 to t. So this I will end up getting s minus 0 is equal to u times t minus 0 plus a times t square by 2 going from 0 to t. So I will get s is equal to ut plus, it was a t square minus 0 by 2, which we will end up getting s is equal to ut plus half a t square.